is just review because we kind of talked about this already with algebraic proofs, okay, with properties of equality and properties of congruency. So we're just reviewing these same properties because we're going to use them, but now I'm going to show you when to use it on a figure. So reflexive property, I want you to think of a mirror. When I'm dealing with it for sides and angle lengths, okay, it's either equal or congruent to itself. So what I gave up here are examples using numbers, and then when we're talking about side or segments or angles, so we should see the exact same thing on the between the congruency symbol. So segment AB is congruent to segment AB. It's a reflective image, okay? Now, when we use this property, this is why I underlined this sentence right here. When will this be used? Whenever two figures share something or overlap. So whenever I see two figures sharing a side, an angle, or if they overlap, then I'm going to start using the reflexive property to justify, okay? And we're going to practice that in an image. So we get what I have up here highlighted, add that word overlap because I'm going to show you how that can occur in a figure. So down here, I'm just going to scroll up a little bit. Who needs the top part? Okay. Okay, so what I did, and I need you to kind of add, I went ahead, I need you to, let's go ahead and name the vertices. I went ahead and said ABC because I need you to see how we have corresponding, corresponding parts, okay? And I went ahead and add the right angles just so we can see a right triangle, okay? So add your vertices, and then I'm going to show you what you can do so you can see maybe an overlapping or a shared part between a figure, okay? Let's go ahead, let's add also the vertices. Let's add the vertices right here, this point, let that be D, and add the vertex, not the vertices, well, it is when I look at the small triangle, but add the points D and E. Add those 2 points. Okay, so watch what happens. Watch what I'm going to do, okay? So I'm going to take the large triangle. I'm talking about triangle ABC. So this is my triangle ABC, my green triangle that I'm drawing right now, okay? So if I have that triangle, oops, come here. Come here, there it is. Okay, there's my green triangle, okay? Now, I also have another triangle in this figure, the smaller triangle. Do y'all see? Let's make this one blue. Do we see right here, triangle DEF? Okay, so if I was talking about corresponding vertices, I wanted you to see that my vertice E, oops, go back. Sorry, come down. Right there. Right there. No, undo. There we go. There we go. Okay, my vertice E, calm down, corresponds with my vertice B. Everyone agree with that? Okay, so what I want you to see is that angle. What letter? C. Angle 1 is also angle C. And angle 1, come on. Now it doesn't want to work for me. Can y'all stop, please? There we go. I want you to see how they overlap on C, okay? So angle 1 right here, this is our shared angle in both triangles. They're overlapping. Okay, this is where the overlapping angle is. And whenever we have an angle that's being shared or is on top of one another, okay, that shared angle, we're going to use the reflexive property to justify when we prove. Angle 1 is congruent to angle 1, and it exists in both triangles, the large triangle ABC and the smaller triangle DEC. Okay? So that's what we call overlapping or sharing an angle. When we see that, if I ever see a statement that's stating basically the same thing, that's basically our reflexive property. So if I see an overlapping angle or a shared angle, I'm stating it using the reflexive property. Now look at the second triangle. the white and the gray. Okay? Do they share a part or a side? They share the line CD right here. So we're going to highlight the shared side. Because they share a side CD, there's my reflexive statement. CD is congruent to CD. So wherever I see the shared side, I'm going to use a reflexive statement. Okay, so here's our reflexive. Okay. All right, now, oops, I went the wrong way. Symmetric property, same thing, we're looking for a switch. And I just showed an example of that. If you end with 6 equals x, I can switch it to x equals 6. So we're going to start seeing switches on sides. Here's a switch of a segment. CD is congruent to segment FG. We switch it to segment FG is congruent to CD. And you're going to start seeing switches with angles. And then this is part, we're going to have to make an association. We've done substitution with algebraic proofs. I want you to start realizing if I see a substitution with geometric properties or geometric relationships, we're going to state the transitive property. They mean the same thing for geometric proofs. Okay? And this is just an example. Okay? So think substitution, transitive property. All right, now, oops. All right, next page. You have like a table full of vocab. Some of this vocab we already know, so we're just gonna review it. But there's some additional things, facts we're gonna have to start claiming and stating. All right, 1, right angles. We should know all right angles are congruent. Okay? All right angles are congruent. So if I have one, I have all. Vertical angles, we should know now vertical angles are congruent. We're going to now justify looking at a figure, identifying vertical angles, naming them congruent using the vertical angle theorem. The theorem states that they're congruent. So I know you don't have those intersecting lines, so let's add them to your box. You can do maybe just 4 instead. I think I did 5 lines. No, I did 4 lines. I should have just did 3. But let's get these angles on here. And I'm going to show you how we're going to state the relationship and justify using the theorem. So you're going to now have to read facts off of a diagram. Here we got 8 angles. Who can give me a pair of vertical? 5 and 1, right? Yeah, okay. So here's how we would state it. 5 and 1 we know are vertical. So the vertical angle theorem states that we're going to write angle 5 is congruent to angle 1 by vertical angle theorem. And I'm just going to abbreviate that. You're going to start getting a habit of justifying your step or your statement, especially your congruency statement, using a theorem or postulate. Okay. Sit up, please. All right, linear pair. Make sure we know that if it forms a linear pair, they are supplementary. Supplementary means what? Yeah, they equal 180. Have a sum of 180. Okay, so I just gave you examples of linear pairs, what they could look like. Make sure we have adjacent angles and they form a straight line. The sides are opposite rays. So if I'm talking about non-perpendicular, we're going to have an acute and an obtuse every time. Doesn't mean the obtuse is always on the left side. It just means you're going to have an acute and obtuse angle. Or if you have a right angle perpendicular lines, then what I need you to understand is if I were to, because a lot of times when they label, they do it like this. They just put the box on one of the sides, the right or left. That box is a symbol for 90, right? So if I write it for one, I'm saying it for the other. I do not need to put the box over here too. All I need to do is write it on one side. And I'm proving, because I know that they're supplementary. So I know this is 90 as well. So have your examples of linear pair. And then we're going to do the congruent supplement theorem together. This phone today. Okay. This is new. This theorem is new. You are going to be asked to recognize it and apply it on the online assignment. So, congruent supplement theorem states that if two angles are supplementary to the same angle, then they are congruent. Okay? Now, here's how I'm trying to show you this. There are three angles here, right? Okay? Right now, I'm trying to show you that the red angle and the blue, the acute and my obtuse, if I put them and made them adjacent, I know that's not perfect, but they would make a straight line. They would be supplementary. Does everyone see that? Okay, so right now, my red and my blue are supplementary angles. Two angles are supplementary. They're supplementary to the same angle. So I know red is the supplement of blue. But and I'm going to have to rotate this bad boy. Come on. Let's do it. Like such. Okay, so if I now make this green angle supplement to blue, now the green is supplementary to blue, right? So now we have two angles supplementary to the same angle. That same angle is the blue angle. Then what can I say about the red and the green? They are congruent. So if I was to rotate this again, if it lets me, like such, and then I can rotate a little bit more, and I can see they kind of overlap to be, I'm not getting it perfect, but they are the same angle, okay? So whenever two angles that are supplementary to the same angle, they are congruent. All right, now I can show you that algebraically. Write this down. Angle 1 plus angle 2 equal 180. So that means they are supplementary. Write it down. Now I'm going to state the angle 3 plus angle 2 equals 180. Okay? So when solving using supplementary angles, if I say if the measure of angle 1 equals, let's say, 35, okay? If the measure of angle 2, equals 35, then the measure of angle 1 would have to be what? If the measure of angle 2 equals 35, then the measure of angle 1 I heard it, what? 145. Okay. So remember that. We know that angle 2 is 35. This is angle 2, it's 35. We just calculated that angle 1 is 145. Look what's going to happen. Angle 3 would have to also be 145 to have a supplementary angle. So they are congruent. 1 and 3 are congruent. They're supplement to the same angle, angle 2. So do y'all see that? Okay. Now, what we just did with supplementary, you can do also with complementary. So congruent complementary theorem. Again, highlight the key information. Two angles are complementary to the same angle. They are also congruent. I need you to add this figure. It kind of illustrates that relationship. So add the drawing in the box. What I want us to see that with this symbol showing 90 degrees, 40 and X are complementary. Okay, 40 and Y are also complementary. X and Y are complementary or complements to the same angle, the same amount. So they are complementary to both 40 degrees. So what's the complement to 40? 50. So X would have to be 50, and Y would also have to be 50. So X and Y would be congruent. Do we see that X is equal to Y, which equals 50? Got that down? Okay. I feel like, oh, the last thing. Ben, sit down so they can see, please. Okay, the last thing, your last two boxes, okay, are dealing with, no, I went too far. Right here, are dealing with definition of congruent angles or congruent segments. It's the same relationship. The key to this is vice versa, okay? Meaning I can go in both directions. The definition of congruent angles says that if the measure, or let's say the angles are congruent, like I had up here, your example is if angle 1 is congruent to angle 2, that's the congruent symbol, then the measure, this lowercase m, italicized m, the measure of angle 1 equals the measure of angle 2. So if I state that they're congruent, then you can conclude that they are equal. Vice versa means now, instead of starting with congruency, I could start with equal. Let's say AB equals CD, okay? If they equal, then what can I conclude? Yeah, then the segment AB is congruent to the segment CD, okay? And vice versa. So there's going to be times where they're going to give you the congruent, and you're going to have to tell me that that means that they're equal. Yes. Yeah. All right, last thing we're going to do is the example together. There's some parts to it that I need to make sure you understand when reading a diagram or using it to problem solve. So on your example, I boxed this first statement right here, okay? The measure of angle FHE equals the measure of angle BHG, which equals the measure of angle AHF, which is 90. That's a given statement. They're telling you that. If they give you something, they tell you a measurement, then we have to label it on the diagram. So I'm going to do each one. Here is my FHE. I'm going to put a box to show that that's perpendicular. That's 90 degrees. My BHG is right here. So do you see now that BHG has a pair of complementary angles? Which angles are complementary? Give me the numbers. Yeah, so for BHG, angle 1 plus angle 7 would be equal to 90 because they're complementary. Then we also have AHF, okay? So if I just kind of trace that. AHF is right there. It also has a pair of complementary. So which numbers would go with AHF? Yeah, so I could say the measure, or angle 7 plus angle 6 also would be 90, okay? Now here's how you read it, okay? One, if you see the word if in front of, if the measure, that means that it's not going to stay that measure for each problem. It's saying if it is. So if I'm looking at angle 3 being 30, just looking at the figure, we should be able to give the measure of angle 6. Well, what the measure of angle 6 is if angle 3 is 30. It would also be 30. Now we're going to justify it. That's the part of proving. This is the part we're going to add and get into. I know it's 30 by what tells me it's 30? Yeah, so the vertical angle theorem. The vertical angle theorem stated that vertical angles are congruent. Okay? So now, the minute I come to this problem, I'm just going to scroll up just a little bit. Now it says if again. If BHF is 15. So that 30 doesn't exist anymore. Does everyone understand that? Okay, so BHF, if I'm talking about that one, that is all the way around here. Okay? They're telling me that that arc is 115. And they want us to find the measure of angle 3. We should know the measure of some other angle. BHG, yes. The 1 and the 7 we already know is 90 degrees because they gave us that fact. So what can we do to get to angle 3? Yeah, find this missing part right here. Subtract the 150 from 90. That would give me angle 6, right? So that's going to be 25, right? And then that's vertical to 3. So that would be 25 degrees. Okay? All right, so, well, I wouldn't prove, I would have to first find, I would have to state that angle 1 and 7 is 90, and then use substitution, because I know that 1 and 7 and 6 is the 115. Like, I would have to, I don't have to do all that, though. Okay. Now, not yet. We're not, yeah. Okay. Guys, oops, I went too far. Here is example 2. So this is what you're adding to your spiral that I'm going to check for. There are 2 examples that are tables. Yeah, the no pages that you skipped. Okay? This will be on Edmodo for you to complete. Do we have that? Copy off of Edmodo. Yes. Okay. Huh? I'm not going to have the complete. It's just going to tell you how to fill in each step. Yes.